Section 4.4, function, operations, and compositions. We will see function operations and compositions functions, basically.
Let's look at the function operations. It is possible to define four operations between the functions, and we can use these operations to get new functions. Now, here we define the sum of two functions as the sum of the values of two functions at the point x. So this is a new function f minus g of x, which is defined as f of x minus g of x. And in the same way, f times g of x is equal to f of x times g of x, and f over g of x is equal to f of x over g of x. Here, of course, we have this condition: gx should not be equal to 0. Now, the domain of these functions, especially these three of them, the addition, subtraction, and the multiplication of the functions, the resulting functions, the domain of the sum of the functions and the difference of the functions and their product is equal to the domain of f intersection domain of g. So for these functions, the domain of these functions here, this one or this one or this one, can be found by intersecting the domain of f and domain of g. In the fourth one, in the quotient function here, the quotient of f over g or f divided by g function, we find the domain this way: domain of f intersection domain of g, and then we remove the x values from this, remove the x values such that g of x equal to 0 from this set. So we find this first, and then we find these x values, then we remove this x values from this intersection.
Okay, let's evaluate these functions. It says let f of x is equal to x squared minus x, and let gx is equal to square root of x minus 1. And it says find f of g of 1 and f of f minus g of 2, and f times g of 3, and f divided by g of 4. So by using the definitions of, remember this, the new functions. So what's the definition of this? It will be equal to f of x plus g of x. So then you will put these values first in f and g, and then you will get the values and add them. So let's see. Now the first one then is equal to f of f plus g1 is equal to f of 1 and g of 1, and there is sum. So it's, when you put it here, is f of 1 is 1 squared minus 1, and then here this one is square root 1 minus 1, it makes 0, here 0 here, and 0 here, it becomes 0. Now when we do the other one, f minus g of 2, f minus g of 2, so we put f of 2 and then g of 2, which makes 2 squared minus 2, and this will make 2 minus 1. So it makes 1 here, so it will be 2 minus 1, it will be 1. So f times g of 3, so you just put 3, you just evaluate the function at 3 and g at 3, and then you multiply them. Now for f of g, f over g of 4, so you write f of 4 here, and then g of 4, you calculate this one, you calculate this one, and this will become 12, and this will become square root 3. Okay, this is the answer correct, But we can rationalize the denominator by multiplying square root 3 both sides. So it's mathematically it makes 1. So indeed it will change only the appearance. The mathematical value of this will be same as this one. So because it's obtained by just multiplying with 1. So it's just 1, but the appearance will change. So you got 3 here, and there will be cancellation. It's 4 square root 3. Let's look at this example, and it says find each of the following by using the graphs of f and g. Now f is this and g is this. How to find f plus g of -1? So we have to calculate f of -1 plus g of -1. Now, how do you find f of -1 from the graph? This is the input, this is for the x, and this is for the y, right? So so this is here, this is x. This x is -1. So you will come to the graph of f, and you will find x equal to -1, and then you will get corresponding y value on the graph, so it will make 2. So you say f of -1 is 2 from the graph. Now g of -1 is the same thing, so you look at x equal to -1 and to find the corresponding y value on the function, which is -2. So you say this is -2. So what is f plus g of -1 then? It will be equal to f of -1 plus g of -1, which is 2 plus -2, which is equal to 0. Now, we will do the others in the same way. The only thing is we have to find them from the graph. F of 0, what is f of 0? So take x to be 0 and check for y. X 0 means x equal to 0, and look at the point on the graph, it's still there. So we have 0 over 0, 0 comma 0, x is 0, so the corresponding value will be 0. So f of 0 is equal to 0. Now, what about g of 0? G of 0 is, okay, we will come to x here for x will be 0. And what is y value in g graph? Okay, in the graph of g, you find x equal to 0 and find the corresponding point on the graph of g. And then this becomes y value -2. So you say it's -2. And then we put them together, we get equal to 2. And f times g of 1, and which gives us this. F times g times 1. So you find 1x here, x is the input and this is the output. And we are looking for y value here on the graph of f. X equal to 1, you find x equal to 1 and look at the graph of the function f. We'll find the corresponding value. This is f of 1, this is 1, this is f of 1. So we will say it's 1. Now do the same thing for g. Got -1. So when you multiply them, you get 1 times -1. Now g of f of 2, which is okay, which is equal to gf2 g over f of 2, g of 2 divided by f of 2. So we need to calculate g of 2. Where is 2 here on the graph of g? It's here, so this is the point 2, 0. So it means this is x, this is y on the graph. So this is g of 2 here. So then it will be equal to 0. And what about f of 2? It's equal to 2, so this is 0. As you see, we put just, the values. We are trying to evaluate the values at the functions by using the graph. So it will give you 0. Now let's try and check this example. Exercise, f of x is this and g of x is this. Find each of the following. So f plus g equal to 0 is f of 0 plus g of 0. And then now we have this formulas here, so we will evaluate them in the formulas. G of 0 is like 0 minus 2 plus 1. And this is equal to minus 8, and this is equal to 2 plus 1. This makes minus 5. So we get minus 5. And for this one, we will have f of minus 1 minus g of minus 1. And then we will evaluate these minus 1 and the functions. Okay, we will evaluate the functions at this point. So this will give us minus 1 minus 2 cubed. And this becomes minus 3 cubed, and this becomes minus 27. And then this becomes here, okay, I will put it in the parentheses because we have minus here, so it's better we put the parentheses. This will be minus 1 minus 2 plus 1, and this becomes 3 plus 1, so it makes 4. So we end up with negative 27 minus 4. So this will be negative 31. Now in this case it will be negative 31. Okay, it's the rest is almost same like f of g. F of 2 times g of 2, and when you put this f of 2, you will get 0 cubed, and then the rest will be 2 minus 2, the absolute value times, okay, plus 1 times 0, you will get 0 here, and f over g6 is equal to f of 6 divided by g of 6. And then you calculate 6 minus 2 cubed here, and we calculate g of 6 here. It will be 6 minus 2, its absolute value plus 1, so it will be 4 cubed divided by 4 plus 1. It makes like 64 divided by 5. Now let's solve this example. It says let f of x equal to x squared plus 1 plus x, and let gx equal to x plus 2 over x minus 1. So we will find the formula for f of f plus g of x and f minus g of x and f times g of x and f over g of x, and we will determine their domains. Now the finding them, these values are easy. You can directly write their formulas and you can find them. We basically write the formulas here, and if we need to add them, we add them. For if it is addition, if it is subtraction, we subtract. If it is multiplication, the definition of this one is equal to f of x times g of x, so we multiply them. And then if it is division, we divide them. Now one thing is when finding the domain, okay, when finding the domain, always when finding the domain, use this formula. Here's f, here this domains of these three, it's domain of f intersection domain of g. Now the domain of this one here will be equal to the domain of f intersection domain of g. Then we remove the zeros of g of x. So we have to keep this in our minds. This is important because you don't try to go from here. So some students are doing this first. They do simplification, flipping, and they do this x minus 1, x squared plus x. No, when it is simplified, I think when it is flipped, so we will get this one. It's x minus 1 times x squared plus x divided by x plus 2. Don't do this one for the domain. I mean, you can do it, it's okay, but when calculating the domain, don't do it here, because this might change some of the things. Now, for example, I want to show you this one here. If you write, for example, what happens if we try to find 1? So this one will make you f of 1 divided by g of 1, and this f of 1 is a 1 squared plus 1. And what is g of 1? G of 1 is undefined because of here. It's undefined. So then you will say it's undefined. The whole thing is undefined. But okay, 1 is not in the domain. So clearly 1 is not in the domain of this function, right? So 1 is not in the domain of f over g. But if you do the simplification, if you write it this way, like if you skip this step, and if you do the simplification or the flipping here, you write this one, you will get this. So when you put here 1, you get f over g of x and 1. If you use this formula, it will be 0 times 2 divided by 3, so you will get 0. But this is not true, because we have to use this definition, f x over gx, and when you do it this way, you will see 1 is not in the domain, and otherwise, yeah, if you should not skip f of x over g of x. So for this reason, don't try to find the domain by using simplified formulas. Okay, don't use this one here. Don't use this. Don't use this for domain. You have to use the domain. I mean, you have to use g of x and f of x separately to find the domain. This is an important thing to do. Okay, now how can we find the domains of such functions here? So we said for 3 of them, it's a domain of f intersection domain of g. So it's better we find the domain of f and domain of g first. Okay, here the domain of this function here is, it's obviously it's a power function, and this is x. So for any x value, a polynomial is defined everywhere. So the domain of this function will be all real numbers, because you can take the square of any real number, you can add it with another real number. Now when it comes to here, the domain of g is equal to all the real numbers. Okay, this accepts all real numbers, but this one here, it should not be equal to 1. So we take all real numbers except 1. So if you write it in interval notation, it's this. Then we will write the domains of these functions here. So for these functions, the domain of all 3 of them You can write f minus g or the f times g. All domains of all these will be equal to the domain of f intersection domain of g. So what does this mean? This means you're intersecting this domain of f with all real numbers intersection with domain of g, which is okay, instead of this I will say real numbers. All real numbers, I will use this notation here, real numbers intersection with this domain, which is okay, I'll write it as so what is the intersection of this? So the real, all reals, if you take the set of all real numbers, you intersect with another set, and since this is the biggest set, the real numbers is the biggest set here, so the other set will be the intersection. So the intersection of these two sets will be equal to second set, because the all real numbers, this real numbers covers this one, and the intersection will be only this. Now, when it comes to the domain of this function here, this domain, we will find the domain of f and g, f intersection g, which is this one here, and now we will remove the zeros of g. Now, what is the zeros of g? Let's check. So here, what is the zeros of g? So the zeros, okay, gx is this one. Now, a zero of gx is the value that makes it 0. So it's clearly x equal to minus 2 is a zero of, is a zero of, or the root of g of x. So what we have to do is now the g domain of f over g is the intersection of the domains, so which is this one. Then we have to remove, okay, this element from this set. How can you remove it? You just remove 2. So if you remove 2 from this set, you will see that remove minus 2. Sorry, you will remove minus 2, and this will give you. Okay, I want to show you how to remove it. So this is the set here. We have from 1 to infinity. No, it's from 1 to, yes, it's 1, it's here. So we already have this one here. This is our set, and we want to remove this, the point minus 2, the minus 2 is here. So okay, when you remove this one, you have to make this one empty. So it's removed. So the set will be here as minus infinity up to minus 2, then parentheses minus 2 to 1, and then 1 to infinity. So this will be the domain of f over g. As I said earlier, it will be the domain of f intersection domain of g, and then we remove the 0 of g of x, so which is minus 2 here, so we remove it and we get this one here. And if you write it in scientific in interval notation, it's this set. So you can directly use this formulas to get the domains here. So you don't need to do the job here. I mean, you can do now, once you get the domain, so you can do simplifications here if you have some other things. But first, when finding the set of inputs for each function here, first you have to do the domains. You will find the domains as it's given here. So these are the rules for domain. Let's solve this try and check example here, the exercise. let f of x equal to square root of x, and let g of x be x squared over x minus 2, and we will find f plus g of x, and f minus g of x, and f times g of x, and f over g of x. Now these are easy. You just write f plus g as sum of f of x plus g of x. You just use their formulas, you add them, you subtract them, and it will be square root of x minus x squared over x minus 2. And when it comes to f times g of x, so it will be square root of x times x squared over x minus 2. And then f over g of x is equal to square root of x divided by x squared over x minus 2. Now, when it comes to domains, so let's remember this, the domain of f plus g or f minus g or f times g, they're all equal to the same set, which is domain of f intersection domain of g. Now, how can we find the domain of f and domain of g? So first we have to find them. What is the domain of f? So when you look at the formula here, the square root of x, the square root of x only accepts positive numbers over 0. So it means the domain of f should be all positive numbers including 0. Now, what about g? Domain of g will be equal to what? The domain of g should be all real numbers. This is in the numerator there is no problem, but in the denominator this should not be 0. So what makes it 0? 2 makes it 0. So we remove 2 from the all real numbers. So this is the domain. Now we intersect these two sets. So we intersect 0 to infinity intersection with, okay, let's make it big parentheses here. How can you take the intersection here? So I will make this one here first. Let's make this one a real line. I will put the real line, and I will say here it's 0 to infinity. This is a set we have. Now this set here is minus infinity to minus. You have to start them from the same place. Okay, 0 should be here as well. And now 2 is somewhere here, right? So it comes up to 2, and it doesn't include 2. It goes to infinity. So here is the set. 2 is not included. Here 0 is included. Now, what is the intersection of them? Now look at here. No intersection here, but there's intersection here of starting from 0, goes up to 2, and 2 is not a common element. It's not mushtarak, but the others, they're all common. So you can write all of them as from 0 to 2, 2 is not included, union 2 to infinity. So this is the domain of f plus g, f minus g, or f times g. When it comes to the f over g, okay, here when it comes to domain of f over g, now we take this domain, domain of f intersection domain of g, which is this one here, and then we remove, okay, we take this one and we remove the the point which makes g of x equal to 0. So what makes g of x equal to 0? So let's do it here. Gx equal to 0 means, so what makes this one equal to 0? It only x equal to 0. So the 0 of g is equal to 0 of 0, g is equal to 0, so we remove 0. Okay, it's because of this fact here. Now if you remove it, so I can write here subtraction, but this is set subtraction. Now you remove this 0, so if you remove this one, this will be 0. So you see here, now 0 is not included. You see the bracket here and you see the parentheses here, curly parentheses, 0 not included, to 2 union 2 to infinity. So this will be our set. Now composition of functions. Now this is another way of generating new functions from the two functions. Now f and g be two functions, and their composition is defined by this. Okay, this f composition, it's the notation is here. This notation means f of g of x. So as you see, g of x is an input inside f. Okay, it's an input for f. So you can think of this. First we put x, we evaluate gx, gx is the output now for g, and then we put gx as an input to f. So then the result will be f of g of x, which is, we call it f composition g of x. Now the domain of f of g is the set of all x values such that x is in the domain of g and gx is in the domain of f. So you have to check like this for the domain of f composition g. It's a little tricky here because you have to check if this x makes a problem here or not. Then you have to check also if gx makes a problem here or not. Okay. Now f of x is this and g of x is this, so it says find f g of 2 and g of f2 and f of gx and g of fx. Okay, and then show that they are same. I mean, they are not equal, sorry. Now by the definition of composition, this is f of g of 2. Now first we have to evaluate this. What is it? G of 2 is, by using this formula, we get 2 plus 1, it's equal to 3. And we put it here, f of 3, which is, okay, f of 3. So we use this formula, it will be 3 squared, so it will be 9. Now when it comes to this g of 2, okay, be careful about the order here. The order is important. G of f of 2, and which is f of 2. Okay, you have to apply this rule here. F of x is equal to x squared, so you have to write f of 2 equal to squared. So it will be 4 now. Inside it's 4. And then g of 4, we use this formula here now. It's 4 plus 1, it's equal to 5. Now f composition g of x, f composition g of x is this one here. First you write this g of x, what is it? This is x plus 1. Then you can write this x plus 1 inside. I mean, you put it here, x squared, x plus 1 squared. It will be, okay, you can expand it now. You can leave it as it is, but also expand it, so it will be x squared plus 2x plus 1. Now, when it comes to the g of f of x, okay, I will write it here again. of g of x is, we already found it, it's here, this one, x squared, x plus 1 squared, or x squared plus 2x plus 1. Now g of f of x. F of x is what? This is x squared. So then gx is x plus 1, so it will be x squared plus 1. Right? This is, you put here gx is x plus 1. And you write g of x squared as x squared plus 1. Right? Change x with x squared, you do the same thing on the side. So you get this one. Now it says, show that they're not equal. This is obvious because these two functions are not equal because they don't have the same formulas. Okay, here it is done this way. Okay, let's do this try and check exercise here. Okay, I will make it quick here. Like this one here is f of g of 2, and g of 2 is like 2 to the 4th, so it will be f of 2 to the 4th. This is 16, so put it here, so it will be, okay, f of 16, which is equal to square root 16 plus 1, which makes 5. So I will say this is 5. And g of 4, g f of 4, g of f of 4 is, so what is f of 4? So f of 4 is this one here. F of 4 is square root 4 plus 1, it's equal to 3. So then we have to replace this one by 3. So what is g? 3 to the 4th, which makes 81. So I will say this is 81. Then f of g of x, so then you have to write f of g of x here. What is g of x? Write the formula, x to the 4th. So what is f x to the 4th? Okay, f x to the 4th is, okay, I want to show you this one clearly. And this becomes x squared, the absolute value of x squared plus 1, but you can remove the x squared, the absolute value, because it's x squared. So this will be equal to x squared plus 1. This here is x squared plus 1. Now let's look at here g of f of x. G of f of x is, okay, what is f of x? F of x is square root x plus 1. And then, okay, now here comes the question, what is g of square root x plus 1 if g is x to the 4th? So we do basically replace x with the square root of x plus 1, so it has to be this. Now I will not try to expand it. it's a binomial type thing, but it will take some time. So this is the answer for this one. Like if someone wants to do it, like you can do this first, do this, then take the square of the result, and you will get this one. Now let's solve this problem. Sometimes the functions are given by using a table. Let's look at this table. It says by using the following table, find f of g of 2 and g of f of 2. And now let's look at what does this mean. It means f of 1 is equal to 0, f of 2 is equal to 3, f of 3 is equal to 4. So it goes this way, like here, for example, this one means f of 1 equal to 0. And here it means f of 2 equal to 3. And in the same way, what does this correspond to? This is g of 3. G of 3 is equal to 3. So it's a table. Now it says find f of f composition g of 2. So it means, what's the meaning of f composition g of 2? This means f of g of 2. So what is g of 2 first? It's 4. So from the table you have 4. What is f of 4? So f of 4 is 5. So the answer is 5 for the first one. Now if you try to do the same thing for g of f, first you have to evaluate f. So this is the here gf, okay, this is important. Now g of f of 4, what is f of 4? You go to 4 and you look for the corresponding number. This is 5. G of 5 is minus 2. So the answer is minus 2. Now let's do the same question by using the graphs. So it is important to read, you should know how to read the graphs. So the graphs of functions, you should be able to use the graphs of functions and evaluate the functions by using them. And this is one exercise doing this. Like f of g of 1. So how do you write it? As f of, okay, f composition g of 1 is f composition g of 1. G of 1 is 1. Okay, here it says like this one here, if you want to find g of 1, this is x. So if you want to put g of 1, you find the x value here, 1, and then you go to the graph of g and the corresponding y value. So it will correspond to f of 1, g of 1 on this graph. So it's equal to 1. So we do the same thing for f of 1. What is f of 1? You find the x here at 1. And now you go to the graph of f, and you will look for the corresponding y values again, 1. So you say this is equal to 1. Now let's do the other one. G of f of 2 is, we know it's g of f of 2. Now we have to find first f of 2. Where is f of 2? How can you find it? So you look for x equal to 2, and then you go to the graph of f, and you find the corresponding y value. This makes f of 2. And then this will be f of 2 is 4 then, right? So you write here 4, and you do the same thing for g. So g of 4 now is what? Take x to be 4, find it, and go to the graph of g, find the corresponding value here, it's 4 again. So this time you write g4 is equal to 4. According to this graph, 4 is also equal to g of 4. So then you have g4 is equal to 4, so we found it. So this is g of f of 2 is equal to 4 now. Now find functions. This is one of the types of the questions is this. Find functions such that f of g is equal to, f composition g of x is equal to square root of x plus 1. So in this type of questions, this means f of g of x, right? So it will be equal to x plus 1. Now, it's better you do it this way. I follow this method. First you find g, and then you put g inside f. You put f of g of x. So for example, take x to be x plus 5, and then how can you get x squared of x plus 1? This function is taking x plus 2 to x plus 1. So you can say f of x equal to square root of x. So you can say g is x plus 1 and f of x is equal to square root of x. So when you do this, you will get this one. Like if you want to go a shortcut here, you can say the inside the term under the square root is g, and the square root function itself is f. You can say this way. And it's not one way of, okay, there are more functions like that. One option we said, one answer is this, like you can take this f of x as square root of x, and g of x is like x plus 1. And you can also write in different ways. So it is possible. So you can write here g of x is x, and f of x is same as the square root of x plus 1. You do this. Sorry, this has to be plus 1, and you get this one. As you see, for this, they're same. So that you can find different functions having the same property. But of course, we do not recommend taking g of x equal to x, the second one. So this is the easiest one all the time. So you can take this way. So let's do the try and check. Now, what is f and g here? So can you find f and g such that f composition g is the 1 over x minus 1? Yes, it is possible. I can do it this way. Okay, we have this 1 over, so there's another function here. So you can say let g, the inside should be looks x minus 1, and then f of gx will be equal to f of x minus 1, and then this is 1 over x minus 1. Then it takes this value and it brings it here. It's replace x minus 2 with x minus 1. So it's better we say the function here is now 1 over x. Then you say f of gx is equal to 1 over, it's f of x minus 1, and it will become 1 over x minus 1. It satisfies it. So this is the answer. And that's it. Thanks for listening. Thanks for watching.